we're going to be building off our interface tutorial that you looked at previously, where you learned about what the 3D preview window is and how to use the graph window or view nodes within the graph window, so you can select a node and view what it's creating in the 3D preview window. And you can see the node's parameters on the left. And additionally, you can see these stickies have their parameters always visible at the top of the parameters window. So we're going to kind of cover visual coding concepts this lesson. And the way that data flows through MetaMachine machines is generally from left to right. When you're coding, or if you were coding, often your code will kind of flow as an entire page at once or from top to bottom. When you're working in MetaMachine, try to imagine that data is being processed from left through to right. There are a few exceptions to this. Those would be loops and table readers. Most of what everyone does in MetaMachine is with fairly standard nodes, and these are always left to right, so you have an input and output connection. So if we click back on this tab and bring up our preview of what we've got, we can kind of begin breaking down what we're looking at. So we have a staircase type at the top, and if we identify the parameter for that in the visual coding window, we can see the stair type here, and it's an enum type. So you can see I mouse over that, and up on the top right corner of the visual coding graph it shows an enum, or I can just click on this and view that it's an enum type. If I change what the enum type is doing, it changes the type of stair that gets built. And the way that this logic is working is that there is a switch here, and this enum is driving the switch. And basically this enum is outputting a 0 or a 1. And the switch is switching between either 0 or 1. And the way it determines that is the order of connection. So the first connection will be 0, the next connection is 1, and any further connections after that would be 2, 3, and 4, and it would go on. So what happens when this enum is changed from slat to solid is this switch is dirtied, and basically the switch is told that it needs to be evaluated. When a node is dirtied, it means that it has had its data changed and it needs to be re-evaluated. So this switch is dirtied by the enum stair type, and it is told that it needs to recover the data that is incoming into it and reprocess it. So because we've changed our stair type from slat through to solid, and the numbers changed from 1 to 0, the switch is now searching. When I click on the switch, it'll automatically evaluate for the 0 incoming connection. So if we open this up, you can see that the solid is coming in first. And what this will do is it will evaluate the solid molecule. So we haven't actually covered molecules yet. So molecules are really the same as atoms or nodes, but they can contain multiple atoms or nodes. If you open up a molecule by double-clicking on it, you'll see a whole lot of nodes inside it. Well, not always, some molecules are very simple. You can navigate out of a molecule by pressing U, which takes you to the upper level. So the way to think of it is every time you go into a molecule, you can have multiple nested molecules. We could create a molecule inside this molecule, is that you're going down a level. So we can see that there are multiple inputs coming into this molecule. And if we open the molecule up, these inputs are visible here. These are sticky inputs. If you create a float, and we'll call it test, and we want this to be visible as an incoming connection on this node. So if I open this node up and view its incoming connections, we can see all of those sticky nodes. And we covered what sticky nodes were in the previous lesson, but just to reiterate over it, a sticky node is a node that has had its attributes made sticky. So if I right click on this node and say sticky, it will now appear as an input. You can see test written down here as the last input added to this molecule. So if I copied this test float and added it down here, I could add a test parameter to this molecule. Which isn't actually doing anything at the moment and will remain not doing anything for the time being. But we'll continue looking at what's happening inside this molecule. So these variables are coming in, or parameters are coming in, and driving the way that things are made within the molecule. So this tread height is telling a vector the point at which it is going to create a point, and then these points are connected to a points to curve. So if we come down into the 3D preview window, it's very small. It appears very small. If we press F, we can frame what we're looking at. So we have a single line, and that line will get copied multiple times. So if I look around here now, we now have a series of lines. And what's coming out of this copy molecule is the geometry, and the geometry is coming into points to curve. So what points to curve is doing is it's actually evaluating the points coming out of the copy molecule. It's not using the geometry, it's not paying attention to the lines, it's just paying attention to the number of points. So we can bring up the number of points in this view by pressing N. So if we zoom in and have a look down the start here, we can see the first point is called 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth. And points to curve is connecting in that order. So we'll keep on moving along this molecule's creation. We have some extra points added, and these points are being created by finding the number of points. So the number of points have been found in this points to curve list. So out of this points to curve, the number of points have been evaluated, and then we're getting the vector, which is essentially a point. We're getting the vector point that is the very last point of the number of points. We're getting the last vector point, and we're combining that vector list with a point made at the very start, which is the tread overhang point. We're making a curve, so if we shift select that curve and the other curves, we can begin to see what's going on. And that curve is scaled. I see. And that curve has been scaled using the geometry bounds of the original points to curve. And that points to curve is connected up with the new scaled line. And then that path is closed. So again, you'll notice that we're very much flowing from left through to right, and as we flow from left through to right, we have even a new parameter input coming in at this point. We're getting more and more resolved. We're getting closer to finishing our coding outcome. I'm just going to turn off the points. So down here you can see there are so many points now that you can't really make out what's going on anymore. So I'm going to turn that off by pressing N again. Something to note with pressing N is you can actually press Shift N, and that gives you the number of primitives. So you can see there's a 0 there, which generally when you're coding 0 is the first item, and then if there was another primitive it would be 1, 2, 3. So I just press Shift N again to turn that off. And at the end of the day, the geometry output goes into the out of this molecule. And the out of the molecule becomes the out of the molecule node. So I just pressed U to go up a level back to the main level of the machine. And the output of the out is now coming out of here. So if I click on the out of this, it should look exactly the same as just clicking on this molecule and viewing its output in the preview window. We can have a look at the logic inside the slats molecule. It will be very similar. The first part of the molecule probably operates in almost exactly the same way as the last part, or as the last one. Where it will differ is how it starts constructing geometry. So the points to curve is made, it's triangulated so that you get an actual polygonal surface, and it's extruded. And the only real difference is that the extrusion is considerably smaller, and then it is moved. So all that happens here is that two of these extruded polygonal faces are getting piped into the out of this node, and then additionally the other set of objects getting piped into this node are the treads, which have been created using similar but different logic within the same molecule. And again, if I click on the out and I want to view the number of points, which will be fairly crazy and hard to look at for now, by pressing N, or I can go Shift N and view the geometry numbers. So we have 0, 1, 2, 3, so on and so forth. And we can see that 23 and 24 are the last two bits of geometry, and that indicates to me that these were connected last. So 24 was connected last. If I delete this connection in the top in the graph window, then you can see that this string has become 23 and the next string will become 24. So just turn the numbers back off again and go back to the graph window, and we'll go back up a level. So I've just gone up a level by pressing U again. So the cool thing about MetaMachine is it uses what's called lazy evaluation, or call by need evaluation. And this means that nodes will only be reevaluated if they need to be reevaluated. And the way this is done is by dirtying things. We talked about this briefly before. So if the tread overhang changes, it will dirty these nodes and they'll need to be reevaluated. So if I click on them, that means that I wish to reevaluate them. Often other parametric modelers, when they have their variables change or input, they force reevaluation of every node, even if they don't need to be evaluated. So thanks for your time, and I hope that has helped to illustrate what is happening when you create a visual code, and we'll start moving on to creating your own visual codes.